Hi folks, so this is sheet 2. Today we're going to be doing of the oblique planes. And just to have a quick recap yesterday, the oblique planes, what are they? They're a plane that's inclined to both the vertical and horizontal plane. Where these planes intersect with the vertical and horizontal plane, we get these heavy black lines there called the traces, okay? And that is what an orthographic may look like of one. Over here yesterday we had a plan view, and we used the oblique plane to help us find what would an object look like when it has been cut by an oblique plane. Okay, so if you take point 2 here, for example, yesterday, point 2 brought up a line straight above it, basic orthographic. We also brought a line parallel to the horizontal trace that hits the XY line. Then we brought a vertical, and where it hits the vertical trace, we brought it over to find point 2, and the same with the rest. And that works on the principle of rising water. Okay, so that was yesterday's tutorial. Today now, what we're going to be looking at, we're going to move on and we're going to do the opposite of this. So we are going to have something in elevation, but this time we're going to work backwards and find that in plan view. Okay, so if we take any point here, I'll just take point 10 to start us off. Okay, and I'll do this one in color. So if we bring down 10 there, parallel to the vertical trace, and I put both of these actually at 45 degrees just to make it easy. Okay, where it hits the vertical trace, or the XY line, sorry, we're going to drop straight down. And where it hits the horizontal trace, we're going to come across there. And basic orthographic, of course, tells us that point must be below it in plan, directly below it in plan view. So that's the opposite to yesterday. That's how you'd find one point. So I'm going to quickly go through now, and I'm going to stop talking and get the rest of my points. Okay. No, so that's what our object is going to look like when we take it from plane, or elevation, sorry, which is a circle down to planes, giving us an elliptical shape there, okay? Now, the next thing we're going to move on to, and we will come back to more stuff like that again, is finding the true inclination of an oblique plane to the horizontal plane, okay? Now, I'm just going to do a quick sketch similar to yesterday. We'll set up here, up in the top right-hand corner maybe, our vertical plane. Our horizontal plane there. Okay, and again, I'm going to set up here now a cone, a half a cone, okay? Now you'll find with drawing, we'll come back using cones so many times to help us solve things or get points of interest, okay? Now the reason I'm picking a cone actually in this, and I'm just going to put in the trace there as well, is that for every oblique plane, there is a specific cone that will sit in against that plane, and that one generator, on that cone, it will touch the oblique plane perfectly. Okay, so we're just going to be looking in here from the side now. So I'm just going to draw in a generator there, down to touch that oblique plane there. Okay, let's do it a bit heavier now. Okay, we'll just label these up. Now I'm just putting an extra line there. Okay. Now, that will be a sketch of it. So, as I said, there's a specific cone to fit every specific oblique plane. So if we do an orthographic of that, okay, so you could have an orthographic and you could be asked something like, you can just, we'll just eyeball this up, keep it roughly the same. Throw in a horizontal trace there, vertical trace up here. Okay, T, V, H. Now, if I want to find the true inclination, remember these oblique planes are like sheets of glass, okay? We want to find the true inclination of that as it's resting on the horizontal plane. Well, one way we could go about doing that would be like so. If we just pick a point anywhere and put in this line, we'll call it AB. Okay, and we'll put in another line now at a right angle to the horizontal trace, going from B. Let's put that in color like my like my generator. Okay, so that's at a right angle there now. Now I'll just get my compass there now, and I'll throw a semicircle down there representing the half cone in plane. Okay. Now that's like having a generator looking down there in plan view, but what you would want to see is you would want to look in at that perpendicularly, okay? So one way about doing that is we could rotate this extreme generator around here or over to there, same thing, until it hits the XY line. And where it hits the XY line, you could draw in the extreme generator, okay, of that cone. That's also the true length, by the way, as well now. But what you would get out of that, because it started off at a right angle there to the horizontal trace, you would get the true inclination of that oblique plane to the horizontal plane. Okay. One other quick way of doing that there, folks, would be, let's do a quick example here now, is if we just draw a small XY line there. In all of them, sure. And we'll pick a point P anywhere down here, okay? And I'll just get my 30-degree set square to keep it handy. An angle there, any angle at all. So T, H, V. Now that point P, we're going to tell you is on the oblique plane, Now, if I want to find that in elevation, of course, what we do is we bring it up. Let's say Y line. Bring it up there, it's the vertical trace. Bring it across. Bring it up, straight up from plane. That will get you point P in plane. Now, the second way of getting the whatchamacallit, the true inclination of the this oblique plane to the horizontal plane would be to do the following. So if we look along here, okay, we're going to look along this true length line. We'll set up an X Y line. Now, if I take the height of P there, if I measure the height of P, okay, and that height there, whatever that height is, because I'm telling you P is on the oblique plane, we're going to mark that height off up here. Okay, let's draw that in my color again. Okay, that is P there. Now I'll see an edge view of the oblique plane. And by seeing an edge view, I'll get the true inclination, okay, of this oblique plane to the horizontal plane. So two ways about doing it, the cone and an auxiliary. This one works on the principle that even though we know planes go on forever, you are looking of the line I have drawn, the horizontal trace, that is the true length, the portion I've drawn. And there's a rule in drawing, which in geometry, which is that if you, I'll write it down here, if you want to see an edge view of a plane, get a true length, which this guy is, that's the true length there, this line, for the portion I can see of it. Get a true length and look along it. So there we go, folks. So that shows today the oblique plane. Again, we're coming back to, remember, these can tilt off to the right or to the left, okay? But in today's lesson, so what we did was we had an object there in elevation. We did the reverse today and we found out what it looks like in plan view. And then we went about finding the true inclination of an oblique plane to the horizontal plane, okay? And we did that by the cone method or by an auxiliary. So whichever one you prefer, folks, you could run with that. So I hope you found this useful, folks. This is sheet number 2, by the way. And we're going to keep processing through them like this. Okay, so more videos to come, folks. I hope you found this useful and we'll talk to you soon.